Okay, Wildcat. Today we're looking at Monday, August 27th, sets of numbers and notation on page 2. So if you would, update your table of contents. Now, if you're just watching this and you notice that there was a video on the 22nd and the 27th, that's because on Thursday we're going to do a pre-assessment, and there's not going to be a video. You're going to just basically see what you remember from Algebra 1 and Geometry, and then you're going to, on that day, just all see what you can do. And on Friday, we're going to go over it and explain and teach the problems that you didn't understand. Okay, so with that, let's continue with sets of numbers and notation. If you would finish updating your table of contents. All right, now your table of contents are updated. Let's take a look at the first part. Okay, let's take a look at our notes. Okay, sets of numbers and notation on page 2. Vocabulary. Set, a collection or group. Element, an item in a set. Subset, a set within a set. Empty set, null set without elements. Finite set, limited number of elements. Infinite set, unlimited number of elements. All right, so now let's move on to notation. All right, notation. There's roster, list, also known as set builder. Example 1 of that is the alphabet. Example 2 would be positive even numbers. Inequality notation uses inequality symbols. Less than, greater than, less than or equal to, greater than or equal to. Example 3, x is less than 2 or x is greater than or equal to 5. Example 4, x is greater than or equal to -1 and less than 2. All right, interval notation. All symbols, parentheses, brackets. We also use the or and and. So the parentheses represent not equal, and we represent that on the number line as an open, or on a graph as an open circle. Okay, brackets represent equal, and we represent that on the number line or graph as a shaded in circle. This symbol means or, that means and. Example 5. So we have -infinity to 2, not including 2, or 5 to infinity, including 5. Example 6. We have bracket -1, that means we include -1, to 2 parentheses, meaning 2 is not included. All right, so if you would, finish up your notes. All right, now, as we're going through here, let's look at the set of all real numbers. So you should find this sheet. It's the last page of this assignment packet. So if you would just tear that off and let's pull that here. All right, so we have real numbers, which we represent by the double R, and that's all numbers on a number line. All right, so let's start with the innermost circle, okay? That is natural numbers. And we represent that with the capital N. Now, natural numbers are what you think natural. It was natural to count 1, 2, 3, ... Now, natural numbers are a set of all real numbers, or I should say a subset, I guess you could say. All right. Now, the next is you have whole numbers. Which we represent with a capital W. Now, all natural numbers are whole numbers, but not all whole numbers are natural number. And the difference between natural and whole is 0. All right, so the next is, excuse me, integers. And which we represented that as a capital Z. Okay, integers, now important to note, every natural number, every whole number is included in integers, but not all integers are included in natural and whole numbers. That's how this works. So integers started to incorporate the negative numbers. So -3, -2, -1, 0, 1, 2, 3, and I guess you could go ... here and ... here. Now, something important to note about integers is there are no fractions and no decimals. All right, and the last of these is rational, which is represented with a capital Q. Now, something important to note is there is going to be a quiz coming up, and you're going to need to know what symbols represent what. So you're going to need to know that natural is a capital N, whole numbers is a capital W. So make sure you find a way to remember those. Now, rational numbers are plus or minus, fraction, or decimals. Now, these are subsets of the set of real numbers. And these are items within, or I guess you could say an element within the set. All right, now, also included in the real numbers is irrational numbers. They're still real numbers, but they are not included in any of these subsets. Now, irrational numbers are keyword, they're non-terminating decimals. Pi's example, and if you want to understand that, Google the last term of pi, and you'll find that they haven't found it yet. It keeps going on forever. A good example also is put the square root of 2 in your calculator. You'll find that decimal keeps going on and on forever, so does square root of 5. All right, so this is kind of an awkward page to put in your journal, but what I would recommend doing is probably turning it this way, and this is on page 2. All right, so now let's get into the examples, which again is on page 2. All right, so if interval and inequality notation are the most commonly used forms of notation, inequality notation can easily be written in set building notation as well. All right, so we have parentheses. Indicate those values that are not equal to, excuse me, bracket, indicate those values that are equal to. Now, as I'm going through, this is kind of like the first real lesson so much. Now, remember, if you have trouble with this, there's going to be 3 groups in class. 1, where the traditional, where I'm going to go over these examples again. 2, a group where you're working with a partner. Or 3, where you're watching this video in class. Okay, so just know that I have 3 ways to adapt to any of those issues that you might have. Because some of you might need me to go over these examples in class. Some of you watch the video, see the examples, and can start working on the assignment in class. And some of you might be watching this video or the next video in class. Okay. All right. Example 1. So inequality notation. So we are given inequality notation, and we need to put this in interval notation. So x is less than 2, meaning we're coming from negative infinity to 2, not including 2. So what that means graphically is we have an open circle at 2, and we're shading everything leading up to 2. All right, same thing, example 2. We're given inequality notation, and we need to write interval notation. Now, notice how x is in between. So basically, that's what you're going to do with the numbers. So you have -1, 2, 3, bracket. It's parentheses because there's no line underneath, and it's not included. It's a bracket because we have a line underneath. So what that means is we have an open circle at -1 and a closed circle at 3, and everything is in between. All right, example 3. Now, example 3, you notice that we're given interval notation, but we need to write inequality notation. So really, it's real simple. Interval, when it looks like this, looks like this. So we need to write this in that format. So we have -4. It's parentheses, so no line underneath. X, bracket, so line underneath, 5. So what that means is open circle at -4, closed circle at 5, and we shade in between. All right, and so the last of these types of examples is, this isn't OR statement, so we have this or that. So this is -1 less than X less than or equal to 0. Now I've run out of space. I would normally write this all horizontally, but I'm just going to have to write or here and then write the next part here. So then that's 2 less than X, and that's it. Now that kind of looks odd, so you could actually write it like this: X is greater than 2. Both of those are acceptable. All right, so let's start with this. We have open circle at -1, closed circle at 0, and we shade between. With the OR, so OR we have open circle at 2, and we're shading to the right. All right, so now let's look at the next part. All right, on the graph of f of x below, so that's here, looking at this graph right here, okay? On one interval is x of x, is f of x increasing. So we're looking at x is right here. So we're looking at horizontally what's happening, okay? So when we talk about decreasing, well, this is increasing, this is decreasing. So we look right here, this is at 1, 2, 3, 4, 5. So from 5 to infinity, this graph is decreasing. And if you want to think of it like on a number line, and that actually should be a bracket. Actually, no, I'm sorry, it is a parentheses because it's not actually decreasing at 5. So I have an open circle and we're here. So we're really just looking at horizontally what's happening to this graph. All right, on what interval of x is it negative? Okay, so it's negative from, looks like, from here. So I'm saying from negative infinity to positive infinity, because from here it's all negative. All of this is negative. All right. On what interval of x is f of x positive? Well, it never is positive, so the answer is none. Example of when it would be positive if the graph were here. Then the positive values were here. All right. On what interval of x is f of x constant? Again, constant is a horizontal. So like the graph went here, and it was horizontal, and then maybe here. This would be your constant section, but there's no point that it's constant, so it's none. All right, so at this point, if you feel like you understood all the examples, start working on the assignment or wait to class to start working on assignment. If you had trouble with the examples, just know that I'm going to go over those examples in the traditional format in class on Monday, August 27th. So with that, have a wonderful Wildcat day.